Yeah. Let's see. So we need to have. So this website would be. It needs to be.
All right, you got it?
Yeah, now it works.
Okay.
All right, so y'all can go ahead. I'm going to, might want to wait just a minute for one or two other viewers to join, but I'm going to mute our end so that we don't affect you, okay?
Okay, cool.
All right.
I just said wait.
So shall I start from the beginning?
Yeah, please.
Or I can do this.
Did you read it or is just? Okay, I think we can probably.
Okay. All right. So hi everybody again. I hope that someone is hearing me again outside of here. So I'm going to talk about the experience we had in terms of and thoughts process we had in terms of putting together a large-scale open resource for autism imaging research. And I will tell you what motivated us in terms of a child psychiatrist perspective. I will describe more in details the autism brain imaging data exchange because that's the example I know the best and also one probably the only complete examples readily available. I will give you some examples of its usage and recommendations. I will talk about the abide pre-process initiative, a brief overview of what else is there and what's going to happen next, or what's happening right now. The motivation to aggregate large-scale data sets, and most importantly to openly share, came from the awareness that for openly share in terms of for autism spectrum disorder and child psychiatry in general, came from the awareness that nearly half of Americans, and these numbers are not that different likely in the rest of the world, but half of Americans throughout their life, sooner or later, will develop a form of a psychiatric disorder, psychiatric problem. And what this large study, epidemiological study, also showed was that 2/3 of the psychiatric disorders emerge in childhood or adolescence. And I highlighted the conclusion of this study that underscored the importance of recognition and treatment as early as possible with a focus in childhood. Unfortunately, however, unlike any other field in medicine, child psychiatry and psychiatry more generally is quite behind in terms of using the advances in technology and analytical approaches that we have available for clinical applications. And this is in part due to the challenge that psychiatry presents with, which says any psychiatric disorder is characterized by a series of signs and symptoms that we observe or someone reports to you, and so inherently are subjective in nature, despite being obviously also valid to date. So we don't have a taxonomy that is based on biological markers. Psychiatry doesn't come, is not homogeneous. Any psychiatric disorder.
I'm sorry, I apologize, just 1 second. I'm really sorry to interrupt you, but your slides are not maximized, so we can't see them. And I don't know if that is.
What was the question?
Your slides are not maximized. We cannot see your slides.
Okay.
Can you see them at all?
Well, we see them, but they're not. It looks like the edit mode. You understand what I'm saying?
Oh, yes. That means.
Yeah. So what you need to do is.
Oh, it may be.
Yeah.
It may be because they were done on a Mac and this is a PC.
No, that's not the reason. Dave, what you need to do is unshare the screen.
Hold on, Dave just stepped up, so I need that.
Okay. Prantik, please unshare the screen.
Yeah. 1 second. All right.
So when you select screen sharing, go back to screen sharing, but select it and tell it to share the entire desktop, not just the PowerPoint slide.
Entire screen?
Yeah, the entire screen.
Right, that does that.
Okay, now turn on the slideshow.
Hold on. The slideshow is in power and preview, right? Now it's preview.
The slideshow was in PowerPoint.
In PowerPoint. Oh, wait, wrong one. There you go.
Okay, so now it's working fine. Thank you very much.
Okay, good. Okay, sorry for this. I think okay, this is just the second slide. It was just summarizing some of the challenges we have in psychiatry. So I was just saying that psychiatry is based on descriptions of symptoms. Often a psychiatric disorder is accompanied by another one, making the picture and the presentation blurry and confusing and complex. And also the current diagnostic systems are sort of artificial, where we create specific boundaries, clear-cut boundaries between one disorder and the other, but that's not really the case. Anxiety, for example, is a dimension that cuts across disorders. So it characterizes anxiety disorder, for example, but also extends to other disorders in terms of severity, or even if less severe, affects typical developing individuals with the range. And from a child psychiatry perspective, it's also important to think that the targets change as a function of age with the developmental changes. Facing these challenges, there's also the practice so far in research in psychiatry, which has been based on fundamentally small samples, approximate replications, and not real true replications, and extreme comparison. So we compare typically developing people, healthy controls with the patients, and that's not really what in the real life a clinician needs. A clinician can very well deal with these extreme differences. It's the spectrum of psychiatric within the psychiatric presentations that is a challenge for a clinician. And again, we need to think about the changes in development when we deal with child developing disorders. The autism spectrum disorder captures very well all these challenges. And we thought that and it's well known to, it's an early onset disorder. I'm not going to go into details of the clinical presentation of ASD, given the time difficulties we had so far. I just want to mention that not only has these problems, but is also known, or models increasingly characterize autism as a disconnection brain syndrome. There's a wide range of evidence from different fields supporting this model, both from post-mortem evidence of many column abnormalities or genetic evidence of abnormalities of genes that code for proteins that are important in the regulation of synapses, hence communication between neuronal communications. And there are direct evidence from imaging, both structural imaging demonstrating white matter abnormalities and functional imaging demonstrating abnormal functional connectivity. We focus particularly on resting state fMRI, and I go, again, trust me, or you guys know, most of you know, what are the advantages of resting state fMRI that motivate the investment on this approach. But for the point of view of large-scale open science resources, resting state fMRI is also very well suited because it bypasses the potential variation and difficulties related to task designs, ceilings effects, practice, and changes in task from one side to the other. It's also interesting because since it's commonly included as an add-on in many studies, it's sort of for each investigator, with few exceptions, it sort of decreases its value, and so it's easy to share. And most importantly, there's been evidence that the networks identified using resting state fMRI based analytical approaches are very consistent across laboratories. We were thinking about these things 3 years ago, and we looked at the field of resting state fMRI in autism. It was just starting. The applications of this approach were starting. They confirm its feasibility to capture these connections in autism, though the findings were a bit inconsistent. So with the papers reporting under connections and papers reporting over connectivity, and also inconsistent in what circuit, what was the spatial extent of these connections. But most importantly, we noticed that the majority of the studies published were on average reporting on samples of a little bit more than 20 per diagnostic group. Because there was, and this is a problem, obviously, not only because with small sample sizes you can end up reporting false positive, but also you can miss important signals, which is also very important and relevant for the reasons I just mentioned in terms of psychiatric disorders that are highly heterogeneous. And this was very nicely, elegantly captured in this review of 2 years ago that I recommend to go read in details. Fortunately, Bharat Biswal, Mike Millon, first with the functional connectome, and later on Mike with a lot of other people that supporting the INDI projects, demonstrated the utility and feasibility of aggregating resting state fMRI data, both in typical individuals, as shown in the first effort and the PNAS paper of Biswal et al., as well as in clinical populations, as shown by the DHT 200 initiative. So putting all these pieces together, we were motivated in attempting to do an aggregation, to create an aggregate sample in autism. And so we created, so Stuart and myself asked our colleagues in the field to share their data, the previously collected data. Mike and his colleagues of the Indy team were supported us in all the organization of the data. We created an aggregate of resting state fMRI data and T1 images, or all de-identified. But the main goal was open data sharing. So try to release the data, aggregate, organize the data, and release them as soon as organized. For use with the broader scientific community. And before to talk about the ABIDE in the script in more detail, I want to acknowledge the 17 sites, the 17 laboratories that share the data. It's not something easy to do. There are lots of considerations that go beyond this 20 minutes talk to appraise. But I think it's important to thank and acknowledge all the PI investigators and the labs to share the data, some of which were not even yet published. So, which is another point that, if you want, we can discuss about in terms of challenges when you consider to openly share your own work. This is the website currently of ABIDE that describes the initiative. You can download the data. The data are organized in metric, which is a blueprint of an IMH, and the usage agreement only asks you to register in metric and Indy and to use the data for non-commercial purposes. And we also ask to acknowledge the sites and the PI and the grants that have that you use for your own paper. We don't request to be co-authors or to influence your science and your questions, but that's the only thing we ask. The other thing I want to highlight is that the data were also aggregated or organized in other databases. Again, this is a big other chapter, but it was important to try to see how feasible it was to involve big platforms like Coins, Loris, Loni, and et cetera, they are listed here. They all have ABIDE data sets, also de-identified. The reason is that this was an investment and looking forward for next steps. The greater the data, the greater is the complexity to deal with imaging and phenotypic information to select the data sets. And not all labs have these resources available. So investment in this database and design is also very important. And again, these are people who did it. This was completely grassrooted and did it voluntarily. Since its release at the end of August 2012, the ABIDE sample has been used in many different ways, master thesis, grants, publication. This is what is the count of peer-reviewed studies up to August, this August 2015. There are 27 studies. You can see each study listed in the website under manuscript, and you can see what the studies are about. In general, most of the studies are focused on using resting state fMRI data, 21 of them, and 6 use structural studies. Most of them, and this is just by chance, that is 21. 21 also use the ABIDE data set as a primary sample. But other people, and that's what could be done, is also just use this sample or a selection of that sample for cross-validation, just to show the ability to replicate your own data in your own study design. I'm giving you just two examples of studies that have been published so far. One is on functional data, and this is the consortium paper, where we not only wanted to describe the study, but we wanted to, the sample, but we also wanted to analyze, show that despite the site variation, we were able to capture meaningful signals. Here, for example, is the whole brain parcellation-based analysis, where we compare functional connectivity in probants, autism versus controls. And what was interesting in terms of the field at the time, still now I have to say, is that we identified both the evidence of both hypoconnectivity and hyperconnectivity. So what people say it's inconsistent is inconsistent is probably just that each single study captured different these aspects that are present in the same individuals. What we also noticed is that hypoconnectivity was predominant and characterized cortical connections, and hyperconnectivity characterized subcortical connections, mostly in somatosensory areas. So essentially, we highlighted the possibility that these different mechanisms can vary depending on the circuit involved and the underlying function involved. The other example I picked is the example from Paris, from Roberto Toro's group. I don't know if I pronounced this well, Lefebvre. They used the structural data, and what they have been looking at is the volume of the corpus callosum. This was motivated by the fact that in the literature, in the structural literature of autism, it has been always consistently replicated that corpus callosum is volume is abnormal, it's reduced in individuals with autism relative to controls. But as Roberto and colleagues highlighted, these studies, all the previous studies, were underpowered to really detect differences. And when he used the larger byte data set, they did not find significant differences. What is important is not just about highlighting the limitation of prior studies. That's not what it's about. What I think it's really important for this study is the fact that they try to explain what was the inconsistency, and they could do it thanks to this large data set. So, for instance, first of all, they noticed that the relationship between corpus callosum and brain volume is nonlinear. But there's also a relationship between the total brain volume and IQ. Why that matter? Because this relationship between total brain volume and IQ is different between individuals with autism in red and controls in blue, is significantly different. Yet, in the field, especially those prior underpowered studies, it's common practice to try to match the probants, so the patients with autism, and the controls for IQ. Therefore, you are biasing, and given this nonlinear relationship, you are biasing your results. And I think this is really important, not only to highlight the potential utility of large samples that can detect this, but also as a way, if this approach is replicated and these findings are replicated, to really guide the next generation of studies in terms of choices in analysis and sample selection. I gave you some examples. We're very excited about how much Abide has been used and could be used. But it's really, really important when you use this data to really be aware of the variation that is inherited in the design of a retrospectively created data set, created with multiple sites, independent sites, right? This happened after the fact. So the variation, it's very real. This we know, and you and anyone who uses it needs to know it. In this study, this was the original functional connector project. It was very clear that there are significant site effects What the message of that paper was also saying is that despite the significant side effects, there were highly consistent pattern of functional connectivity organization that were known based on consistent with prior literature, and they were also able to capture other effects like known effects like age and sex effects. But again, the site confounds is there. And why the site, what are the sources of confounds could be many. And essentially, we don't know because they can, as summarized in Chauganian paper, the sources of site variation could be related to the acquisition parameters, and you need to learn what the parameters are. It could be related to this, for example, in the resource you would use. In this case, we are talking about a byte, but whatever resource you use. It could be related to experimental design differences. So in a byte, for instance, some sites used collect the data awake with the eyes open, others collect the data with eyes closed, others didn't really care or didn't have the chance. It's not that they didn't care, didn't have the chance to track whether the individual was sleepy, dozing off or not. There are also obviously variation related to the site. And the reason why I'm making this point is because when you do analysis, you can control, you can try to account for these confounds. Of course, you want, and it's not just simply by covariance, which of course you have to do, but you can do this in analysis, for example, for controlling nuisance signals in the functional data. This is a study that I referred to so that you can read in more details. Chaugan, Yan surveyed all the different approaches that can be used for standardized brains in terms of nuisance signal correction. Each has a pros and cons, and you need to be familiar with them depending on the questions or the interpretation or for interpreting your data. The other thing is that variation, as I mentioned a few seconds before, goes beyond the scanning environment and design. It also inherent in the samples, right? So here we have 20 samples, 17 sites, different sample size. Here you can see that you need to learn what is the sex distribution. Simple things like that are very important, especially for autism. For instance, you can see that some sites don't have any female, and a few sites have a few females, but because autism is more frequent in males than females, even the sites who attempted to collect females have a significantly lower representation of this group. There's also variation, can I hide this? There's also variation in terms of age.
Click on the PowerPoint, just click on the PowerPoint.
I'm sorry, yeah. Sorry about this. There's also variation in terms of age distribution by site, and this is important. So if you want to do a study of age-related differences, you may want to look at this distribution and select the sites that have, in terms of homogeneity, and select the sites that have the spectrum, the age spectrum that you are targeting, rather than picking many subjects with different ages for different sites, because that would lead to increased confounds. But the bottom line is that what I'm trying to say is that if you become a user of this data, you need to know the data well, you need to study, you just need to take those 15 extra minutes reading each site narrative of how they selected the sample, why, what measures they used, how they collected that, because that will, and you have to do it before you start your analysis, so you can make good decisions on based on the questions you have in mind. In other words, size is not all. Site-related variation is very real. So make sure to know protocols and sample features for each site to minimize site both in data selection and data analysis. And another thing that is important, report within site along with the across sites results. I just gave you an example. I'll give you two examples here. This is one paper. This is the first classification paper that came out using Abide. It wasn't using, anyway, you can look at the literature to see what they have, the paper to see what they've done. But again, this is an example where they reported the across sites results of the classification showing that the accuracy was slightly more than 50%, slightly more than chance. This classification probably approach wasn't really the greatest, but it was still more than chance. But they also reported how the accuracy in classifying subject drawbacks versus controls vary as a function of site. And this is not just important because you want to ensure your reviewers and your readers that what you are reporting makes sense and is not dramatically confounded, but also because it could be useful in terms of understanding whether characteristic of one site matters more than another. For example, one site may have a bias in a specific IQ or age. In this case, it was hard to really make sense of this variation. I think that in the paper, they mentioned that the length of the time series mattered in terms of accuracy. But in the long run, these are things you have to keep in mind to interpret the data. And this is another example where Kat Allers took the lead on an analysis we did in the lab for age-related differences of the connectivity of the superior temporal sulcus. Again, these are the main effects where we identified connections with differences in age-related patterns between proband and control. But then, again, most of these are in supplementary material, also report the consistency of the findings in the two sites we selected, which was NYU and USM. And the last piece about site is also I want to make with this work of Alex Abraham and Gael Barroquo. Again, apologies for my pronunciation. They're doing a great, interesting work where they are classifying using multivariate approaches, in this case, in Abide. And they are not just doing it intra-site, meaning that the cross-validation is based on a test and a training sample that is homogeneous in terms of ratio, accounting for site representation, but also inter-site, where now they leave out a site and that becomes the training and so forth and so on. You can see that obviously, and that's very interesting, very important, because the inter-site is more representative of the real world, right? You want a test that can work in Michigan, in Mexico, in New York, etc., in Italy, etc. But the other thing that I think it's interesting in this slide, and we'll go back to this, is that the accuracy could continue to improve. So this is approximately 400 subjects per group, diagnostic group. If we had a larger sample, accuracy would improve. So even 1,000 data sets. I actually don't remember if I told you that Abide yielded 1,000 data sets overall. It's not enough for this type of approaches. But there's a difference between data sharing openly and open science. The openly data sharing, it's great, it's very helpful, but open science goes beyond making data available. Open science means that you also share your intermediate derivative, you share the subject list, and actually in that page of the manuscripts that I showed you, every manuscript has the related subject list used for that study, because that will lead to improve the replications. It means collaborations like this Brainhack initiatives. And in this regard, one example of good open science and maximizing the utility of an openly data shared resource is the Abide pre-process initiative that has been led by Cameron Craddock, Pierre Balek, and colleagues in and outside the Neuro Bureau, where they took Abide the data set, they pre-processed using different pipelines. They pre-processed all the data sets, both in terms of the functional data and the structural data. They made this data available. there's inhomogeneities, there's still disagreement on what is the best pipeline, what is the best, or better, what's the best pre-processing step. So they also, for each software, they also use different strategies with and without global signal regression, for example. These data, these outputs are available, and it's strongly recommended to use this because it will just facilitate replications in the future and interpretation in the presence of inconsistency, for instance. One of the problems is when you find results that are inconsistent, is it because of the pre-processing, is it because of the sample, etc. This type of initiatives reduce the confounds related to that type of variation, that source of variation. Another thing that the Abide Pre-Processed initiative did was to create a list to provide a list of quantitative metrics of quality, as well as provide a qualitative metrics of quality assurance of the structural and functional data by 3 independent reviewers. All of this is well documented in the Abide Pre-Processed page, and I encourage you to go learn about this page and initiative and use those data. Beside Abide, there are other resources available that are openly shared. I have to say that we made a review of all of those that are relevant for connectome pediatrics research, and they are in the Neuron paper of last year. This is just an example of the table that provides these resources. Not all of these resources are necessarily relevant for autism. Now I'm talking about autism, this go beyond. But if, for example, I highlight 2. One is the AKI Rockland Sample Initiative, which it's different from Abide or any other initiatives because it's prospectively giving data every 6 months, every 3 months, or 6 months probably. The Rockland sample, yeah. And even if this is a community sample, so it's not about autism, because it collects a wide range, deep range of phenotypic information that include also autistic traits, this could be also relevant for your imaging research, imaging autism research, because you could examine the autistic traits relationship with the brain connectivity or structure, and their relationship with other parameters that are collected. Again, I encourage you to go and look at the page of the AKI Rockland sample to see the very long list of phenotypic information collected. The other one that I want to highlight is the Enigma. At the time last year, there was nothing about autism, but I am aware that right now the Enigma is working on autism. Enigma is based mostly on structural studies, and it's a different model than Abide and Indy because they ask each lab to do the analysis based on free surfer and then give the output. The last one that instead is dramatically, it's very, very specific to autism, is the ENDAR database, the National Database of Autism Research, funded by the NIH. It's really important because right now anyone who has funding from NIH and does autism research is required to give the data. And this database requests a deep phenotypic information. All the information that the site collects needs to go there, including the phenotypic, the genetic, the imaging. And each subject is linked by a unique identifier. So let's say that I see a child now with 7, and this child moves to Ann Arbor. Ann Arbor may recruit that child, or that child may volunteer for a study in Ann Arbor and be connected with this unique identifier. A description of how ENDAR works is in the paper by Hall et al. But also there are a lot of details of the data that are already available, and you could request to ENDAR in the website. In the ENDAR website. The last thing I want to say is that Abide obviously was just a proof of concept, which was a grassroots initiative. We were able to secure some small funding this time from NIMH to enhance Abide with Abide 2, and in terms of just in terms of size, where we want to have a double sample size, where we can split the sample in a discovery sample and a replication sample, but also we want to increase the depth of the characterization of phenotypic information in terms of severity of the symptoms of autism, a range of symptoms that can be captured, the adaptive functioning, the comorbidity with the other disorders, and we also want to provide multimodal data. So there are some sites who collect resting state fMRI, obviously structural for registration at least, and DTI. Those sites, many of those sites already agreed to also share their DTI data along with the resting state. We have approximately 20 sites who are agreeing to participate in this new effort, and we are estimating that we will have 900 new data to add to the original Abide by spring 2016, summer 2016. And most importantly, we want to maximize the long-term effort of Abide by linking the Abide data sets to ENDAR using GUID whenever possible. Again, ENDAR is going to become the status, it is going to become our gold standard and has the potential to have much more variety of data across domains, including genetics, than just Abide. So in summary, open data resources for imaging are feasible for autism in particular, and have the potential to accelerate the pace of discoveries, but we need to use them with care to maximize impact. Be aware of its characteristic and select or analyze with awareness. Open data sharing is not necessarily open science. So for doing open science, we need to share the subdomains, the codes, the derivatives, and Abide preprocessing initiative is an important initiative in that regard. And while Abide 2 is ongoing and it's great, what we really need is to try to find ways that allow to prospectively share data that are harmonized in terms of protocols, both phenotypic and imaging. So stay tuned. And there are many, many people who work on at NYU to collect the data or to help in giving the data, CMI and NKI, at Cornell Medical Center, at USF, Chinese Academy of Science, and other places who have worked for Abide and similar efforts. And most importantly, we keep continuing thanking the families who participate in the studies. And I thank you guys who are here, and I thank anyone that is in the web listening. Bye.
Yeah. Okay. All right. Can you start sharing? There we go. Okay, that's us finished. I think we can take questions now. I don't know if there's time.
Thank you very much. Yeah, there is definitely time. Is there any questions on the getter? I don't think we have any questions here. That was a fantastic talk, Adriana. Thank you very much.
You're welcome.
Are you taking a picture of me on the screen?
Oh, maybe I should. I can pretend that I'm arguing.
All right, how's it going?
Is it really good? Okay.
Gerard. Hello, Zerar. ODB and the hizzy. All right, thank you very much. So, Alex, will he be ready to go up next?
Yeah, we just need a couple of minutes to set up.
Okay, sure. So we'll set it as a different stream, so it'll be archived separately. But yeah, so you want me to give you 5 and then try to invite you to the next hangout?
Please, yes, thank you.
All right, you're welcome. See y'all soon.
All right.